Assalamualaikum and very good afternoon to all of you. Today in this class, I want to discuss about the example 2.1, which is the simply supported slab. Okay, first of all, let us take a look on this example where you have to design a simply supported slab. Okay, a simply supported slab. Okay, this is the slab, a simply supported slab on two masonry walls, okay, of 250 mm thick and 4.5 meter apart. Okay, however, this book has some typo, so this one shall be 1.0 kilonewton per meter square. And then the variable action is 3.0 kilonewton per meter square. Okay, the material is concrete. The concrete is grade 30. Okay, and then the grade is grade 500 for reinforcement. Designed for 50 years and assume the diameter is 12. Okay, so this is the simply supported one-way slab because it is placed on a brick wall. Okay, let's say this is the brick wall here. Okay, this is the top view. This is the brick wall, and this is another brick wall. And then the spacing here is L is equal to 4.5 meter. This one. Okay, and then this is the B. The design of the slab is just like we designed as a beam, and just like the procedure is similar to beam, but the width B here is equal to 1000 mm. So we design for every 1 meter width of slab. Okay, so this one is okay, as I mentioned before, 1.0 kilonewton, excluding the safe weight, then the variable load is 3.0 kilonewton meter square. Fire resistance of 1 hour, exposure class is given here as SC3, and this is the concrete grade. Okay, concrete grade here is actually okay. The calculation for here is using FCK is equal to 30. Okay, 30, not 25. So this one is 30. Okay, this one is 30. Okay, and then okay, this is the diameter of bar. Okay, this means that if we take a look from here, okay, let's say this is the XX means cross sections. So the beam here is like this one. Okay, this is the slab. Okay, and then this is the okay, then this is the brick wall. Okay, so this means the support is only on these two edges. Okay, this part and this part is become the support, and then there is no support here, no support. Usually slab has support at all 4 edges. Okay, slab biasanya ada, this one is a slab and will be rounded by a beam. This is beam, okay, supported by beam. But for these cases, okay, this one is a one-way slab because it is supported by only two. Okay, only 2 edges here. So the loading will go through this, okay, to the nearest beam, and then the half of the loading will go to the other beams. Okay. So this is the slab thickness. Okay, you check the slab thickness is minimum thickness for fire resistance is 80 mm because the fire resistance is 1 hour. So you take a look on these notes. Fire resistance here, okay, by this table 518 in Eurocode 1. For 1 hour here, this 1 hour of fire resistance, the slab thickness shall be 80. Okay, either one way or two way, and this is the value of A actually. Okay, this is the value of A. Okay, if you still can remember, you can refer to the beam design part for fire resistance. Okay, and then this is the estimated thickness considering deflection control. This is okay 4,500 divided by 26. 26 is from this table actually. Sorry, this one. Okay, 7.4 point table 7.4. So this table for deflection checking. Okay, this table. Okay, you refer to these notes. Actually, it's not. This is not for simply supported. Okay. Simply supported beam 1 or 2 way. Okay, for simply supported beam, either 1 way or 2. Okay, simply supported. This is for beam. Simply supported beam and 1 way or 2 way spanning simply supported slab. Because we are talking about simply supported slab. The example is simply supported slab. So the actual value is not 26 but 20. The value is 20 actually. Okay, so this one shall be 20. Okay, so 4.5 meter divided by 20, it shall be 225. Okay, it shall be 225. This is preliminary sizing. The thickness shall be 225, but it's okay because actually based on the real calculation, we can use lower H. Okay, this is only the maximum. I mean, this is only maximum in order to control the deflections, but we can use lower, and then after we finish calculation of shear and main reinforcement, and then we can recheck for the deflection again. Okay, so this one okay, just okay, recall back your knowledge about your okay, so you mean bond is equal to the diameter of bar. Diameter is equal to 12 mm. And then minimum cover with regard to durability, cement durability is 20 mm because here is the table of cover for durability. Okay, here. Okay. Actually, structural design working life of 50 years is class S4. Okay, class S4. The class is S4. And then this is the design. Okay, the 50 years. So the class is S4 and then XC3. You can use this one. Okay, S4 and XC3. So it shall be 25. However, because this one you refer to this clause, recommended structural classifications. Okay, member with slab geometry. Okay, which is slab XC3 reduce class. We shall reduce the class by 1. This one. Okay, we should reduce the class by 1. So from S4 we reduce to S3. So here, okay. So S4 we shall reduce the class to become S3. So that's why it choose 20. Okay, so this one is 20. Cement durability 20. Okay, because we reduce the class. And then for with regard to R60 fire, the A is 20 mm. We refer to this slide before. The H is 80 minimum, and then the A is 20. So we do the calculations. We do the calculations. A is equal to this one. This is the okay. This is your slab. Okay, thickness here is H equal to 180 mm in this example. So the D, the minimum fire here is okay. So A is 20 minus, okay, say bar over 2. Okay, this is your A. To the center of the steel. Okay, so this is C mean fire is 15 mm, 20 mm, and 12 mm. So we choose the maximum value, which is 20 mm as our C mean. So C mean is from this one. C mean due to durability, which is 20 mm. So we can plus C deviations, which is 10 mm. So C nominal is 30 mm. So this is our C nominal. Okay, 30 mm is our C nominal. Any questions up to this level? Okay, I hope no questions. So, and then this is including we have to determine the safe weight of the slab. This is our H. This is the density of the concrete. Okay, so this is our safe weight of the slab, and this is the permanent load. We total up, so become 5.5 kilonewton per meter square. This is the variable actions. So this is the total design actions. Okay, we just multiply the value of QK here and the GK here and the QK is here. And then for every 1 meter width, we multiply by 1 meter, so we can get the new the unit of kilonewton per meter. So this is our loading, and this is how we calculate the shear force, the value of shear force, and this is how to calculate the value of bending moment. This is the formula for simply supported. Okay, for simply supported, we can use this formula. Okay, then after finish, we can move to calculate the main reinforcement. So this is the main reinforcement because this is the slab. Okay, so this is our reinforcement for, okay, to, let's say this is the sorry, how to draw. Okay, so this one is, okay, this is our slab. Okay, our slab. Okay, this is the, okay, 4.5 meter, L 4.5 meter. So the reinforcement here is here. Okay, so we only have to in order to calculate for the value of D is here from the center of the main reinforcement to the top. Okay, to the top surface. So D is equal to, this is the H is equal to, from here, from the top, from the bottom of slab, H minus C nominal and minus the 0.5 of bar. Okay, if I can zoom in, let's say here, this is the, okay, I can zoom in. Okay, so this is the steel reinforcement. Okay, D is the distance from here, from top up to the center of the reinforcement. We don't provide shear link inside the slab. Okay, we don't need the shear reinforcement inside the slab because the concrete itself will be able to cater for the shear stress. So this is the D, and then this is your H. So your D is equal to H minus this one is C nominal. Okay, this C nominal from the surface of the from the bottom surface of the slab up to the edge of the nearest edge of the of the steel minus C nominal and minus diameter over 2. So this is how you calculate your D. Okay, in this example is equal to 144 mm. And then just a similar, just like beam, you have to calculate the value of K. Okay, if the value is less than 0.167, the compression reinforcement is not required. And then you calculate the value of Z. Okay, this is in this example, this is 0.96D, which is greater than 0.95D. So you use the D equal to 0.95 only. This is your Z. Okay. So you just multiply, substitute the value, you got this one, 507 millimeter square per meter run. So you use this table I shared to you before. Okay, this one, you can use this table. Okay, sorry, this, you can use this table. Okay, let me zoom in. Okay, this one, the upper part is for beam. Okay, we have the size and the number and what is the shear reinforcement, the total area for, but for spacing, which involve the spacing, we can use the lower part of this table. Okay, our size is 12 mm. So we check the spacing which is higher than, what is the spacing which will give higher, a bit higher than 507. So you go to this one. Okay, this is you. Okay, you can refer to this table. Okay, this is our size is 12 here. Oh, sorry, I cannot tak boleh contain pula ya. Okay, so let's say I have, okay, kita buat dia. Okay, 12 mm is your diameter, and then 507 is our required. So we have to provide 507. We can provide this one, but this is over design. So we can reduce. Okay, 503, this is lower. So we choose this one, 565 at the spacing of 200 mm. So, okay, the result is we use H12 at spacing 200 mm. Okay, 566 in this example is okay. Okay, so means for every 1 meter of slab, this one, okay, this is our slab. Okay, for every 1 meter run, okay, let's say this is okay, let's say the total here from here to here is 4 meters. So for every 1 meter, let's say this is 1 meter. Okay, we divide. Okay, for every 1 meter, we will use the spacing of the bar is 1 bar. This is 1 bar, H12. Okay, and then for every 200 mm, we will have another bar. Okay, sorry, my drawing is not to scale. I hope you can imagine. Okay, for every 200 meter, this is let's say section A, 1 meter. This is section B. This is section C, and this is section D. Okay, and then for based on our calculation, for every 200 meters, okay, we will lay down a steel bar for bending moment. Okay. So that's why for the slab design, the width of the slab is equal to 1 meter. Okay. We apply for the whole slab. For every 1 meter, we shall have about 5 to 4. So the spacing here should be 200 millimeter center to center. Okay, any questions up to this level? Okay, so this one. Sorry. Sorry.
Every 1 meter, 200 mm itu untuk satu spacing.
Yes, yes. So the spacing is 200 mm center to center, and then you check for shear reinforcement. Okay, before that you must check for the minimum and maximum, and if okay, so 566 is here within the minimum and maximum, so it's okay. So the secondary bar we use a H12 for 450, and secondary bar is okay, let me take a look on the H12 450. Okay, this is secondary bar. This is the primary bar. Primary bar is number 1. This is how to present your detailing. Okay, number 1 means this is your bar. Okay, this is your bar at the bottom. Okay, this is your bar. Okay, this is your bar label. I mean yang melintang ni. Okay, this is your bar here. And then at the top of it, okay, dia akan susun macam ni. Dia akan susun satu bar sini. This is your bar, satu bar. And then transverse, I mean secondary or transverse bar is this one. This is another bar. Okay. And this is the soffit, and this is the C nominal. And then this is the top of the slab. Okay, this is number 2. Number 2 is H12 450. Okay, with this the spacing here is larger for 450, because this is not to cater for bending moment, but we have to provide as minimum secondary bar. So this one for every 450 here. Of course, in the drawing you will not draw for every bars. Okay, you will make your drawing becomes crowded or messy. So you just do this one. This one indicate your bar, and then okay, you do you provide this arrow here to here, and then this dot, and then this is number 2. So you refer number 2 is H12 450. So your drawing is become easier to read. And then this is this. Okay, the bold one indicate your bar, and then this is your arrow. Arrow is from the range of which area to install this kind of bar. Okay, this is the bottom. So 450 is you refer to here, refer to these notes. This is for checking. This is for semi-supported slab detailing. Sorry ya, dari mana datanya 450 tu? You kan tahu tu. Okay, Rabu kita bincang pasal simply supported pula, two way slab, simply supported. So this one, dia ada rules tadi ya, dia ada rules macam mana nak tahu H12 450. Kenapa 450? Ya, checking. Okay, this one. Secondary transverse. Okay, baca ni. Secondary transverse of not less than. Okay, this one. Secondary reinforcement lah. Secondary transverse reinforcement of not less than 20% of the principal reinforcement should be provided in one-way slab. Okay. Okay, in areas near support, transverse reinforcement to principal top bars is not necessary whether there is no transverse bending moment, and the spacing should not exceed the SMAC of the slab. SMAC of the slab for principal reinforcement, okay, maximum is 3H, which is less than 400, less than or equal to 400 mm, but the maximum is 400 mm only. Okay, for principal reinforcement. Principal reinforcement is this one. This is number one here. This is principal reinforcement, and the second here, second bar here, which is spacing 450. This is the secondary. Okay, secondary has to be provided. This one, this should be provided. Should be provided in one-way slab, but the reinforcement not less than. Okay, the area is not less than 20%. So the area here is 566, okay, 566 mm square. So if the minimum is 20%, 20% is equal to at least you must provide greater than 113.2 mm square. Okay, if you refer this table, you can provide actually okay, this table only provide up to 300. Okay, up to 300. Actually, you can maybe you can search in the internet, okay, which will provide larger spacing. Okay, but however, it limited to 550, 450. Okay, let's say maybe if we use H12 500, the value is still maybe around 180 mm square, which is greater than this one, but the limit is 450, so you cannot exceed this limit as mentioned here in this. The spacing should not exceed this one. Okay. Okay, this one ya. Saya tengok. Okay, the spacing should not exceed 4 feet 4 3H. Okay, this one for secondary reinforcement, it should not exceed 450 ataupun 3.5H. Okay, kalau katalah H tu adalah sama dengan 150, so 3.5 times 150 sama dengan berapa? 3.5 kali dengan 150 sama dengan 525, but limit is 450. So you provide 450 only. Okay, and then you check for shear reinforcement. Okay, VED here, so you check the K, and then this is the capacity of concrete to resist for shear. Okay, 78. Okay, 78.7, which is greater than this one. This one is 26.8, is from here, from the structural analysis, 26.8. So you can conclude that the shear reinforcement, okay, shear reinforcement is not required. Okay, so for the then you check the deflection, just follow this step. Okay, make sure that the actual is less than allowable, so it's okay. And then you check for the cracking, you check the allowable, okay, allowable spacing. Okay, maximum bar spacing here 200, because we are using main bar. Main bar also is the principal bar, H12 200, so less than 400, so it's okay. And then this is for principal. Okay, so it's okay. Okay, any question, class, for this example? If you don't have any questions, I like to give you the homework lah. You just redo this example. Just redo this example 2.1, but on this condition. Okay, the condition is your, okay, I write down here. I better write down. Okay. So I give you the H. I give you as 150 mm. I give you, so you can skip. You can skip this step. I give you the H is 150 mm. Okay. Okay. So I better. Okay. Please redo this. Okay. You please redo this equation example. But the L now is equal to 4.0 meter. Okay, shorter, and then this is still 1.0, 3.0. This is sama saja, and then you please use this concrete grade. Okay, 25 still similar. This was still similar, and then you reduce the diameter of bar by 20 mm, and then you directly use your H as 150 mm. Okay, directly use your H as 150 mm. So this is your situation for your example, and I hope you can submit before our next class. Okay, just follow, just take about 30 minutes. Just follow this step. Okay, just follow this step and follow my video later, and then okay, you can refer this step. Okay, boleh buat tak? Just redo the equation. Just redo this example, but on this situation, then you just change the L, and change the H. I want the new H is equal to 150 only. And then concrete, you change to, from 30 you use 25, and then the diameter of bar. That's all. Okay, you just have to change this parameter. Okay, this one say L equal to 4.0 meter, and GK is equal to 1.0 kilonewton per meter square. This is excluding the safe weight. QK is equal to 3.0 kilonewton per meter square. Design life is 450 years. Fire resistance R60. Okay. FCK, you use 25 Newton per millimeter square. FYK still 500 Newton per millimeter square. And then the concrete density still similar, which is 25 kilonewton per meter cube. And then the diameter of bar is equal to 10 mm. Okay, anybody please snapshot this and then H is equal to what? 150 mm. And you can use C nominal. I give you C nominal is equal to 30 mm. Okay, so you can skip this, you can skip this one, and you can skip this one. So you just proceed to the action analysis, and then design the main reinforcement, design the shear, check for deflection, and then check for cracking and do the detailing. Okay, just like this one. I want you to sketch. Okay, sketch this one. Okay, sketch this one, and you have to submit. Okay, you just scan and submit in the Google form before our next class. Okay, this is the only way to make sure that all of you please do this one. Okay, any questions? Okay,
Hamba tak ingat tak sempat.
so please snap this one, send the photo of this criteria so you can do the design later. Okay, thank you so much for your attentions. Okay, that's all from me. Thank you. I hope you can submit before our next class, and then please let the others who not join the class know that I have not assignment but exercise for all of you to do for the slab design. And then for the next class, we will discuss example 2.3 and 2.4. Okay, thank you so much.